Hey everyone, today we're going to be doing some Unit 4 review on rational expressions. We're going to be covering how to simplify NPVs and how to simplify expressions, as well as multiply and divide rational expressions. We're also going to be taking a look at how to do some of the word problems that are in this unit. So, that being said, let's get straight into it. Alrighty, starting with question 1, we're asked to simplify each of the following expressions and state the non-permissible values. So to begin with, I'm going to factor each the denominator and the numerator to begin with, and then we are going to simplify. So we have to find a common factor between our numerator here. So we have 15x and we have negative 6. We can factor out there is a 3. So we have 15 divided by 3 gives us 5, and 6 divided by 3 gives us 2. So that is our fully factored numerator. Now we're going to factor our denominator. So now let's do this. We have 25x squared minus 4. So 25x squared minus 4. So these are all perfect squares here. So we can do our difference of squares formula. So difference of squares is going to be 5x plus 2 and 5x minus 2. Because remember, we have because this square root of 25 is 5, square root of x squared is x, and square root of negative 4 is going to be 2. So get 5x plus 2 and 5x minus 2 as one of our simplified denominators there. Cool. So now what we can do is we can actually cross out and simplify whatever's common. So if you notice here, we have 5x minus 2 on the numerator and 5x minus 2 on the denominator. So cross those both out and you get 5 over x plus 2 or 5x plus 2 as your simplified version. Cool. So what we can do now is we can actually look at our NPV. So what an NPV is, essentially, I'm going to define this. What an NPV is the values of our denominator which cannot be equal to 0. So basically, what an NPV is a non-permissible value, meaning a value that we don't want to have, because remember, if our denominator, so if we have a number, we have a fraction, and our denominator is 0, which is what we don't want, we're going to have an undefined answer, which is what we're trying to avoid. So that is all essentially what an NPV is. It also is about and based on the domain of a function. So if we imagine this being a line here, right? So this original equation here, if this was our line and if it was equal to y here, we would have a break in our graph here, because normally it would be like this, but we would actually have breaks in our graph because we have NPVs. We have values where x cannot equal 0, because there's some values that will give us 0, and we're going to be dividing by 0, which is what we don't want. So essentially, just the values of any variable in your denominator that will give you 0, you don't want that to be equal to. So we have 25x squared minus 4 cannot equal 0. Cool. So we can do this with this is, remember that it factors down into this. So 5x plus 2 and 5x minus 2 both cannot be equal to 0. And we're just going to set each individual bracket not equal to 0. So 5x plus 2 cannot equal 0. 5x cannot equal negative 2. Cannot equal negative 2 over 5. And x cannot equal 2 over 5. So basically, the NPVs in this case are going to be 2 over 5 and negative 2 over 5. So we're just going to pretend like we're solving for x here. But instead of having it equal to 0, which is our root, we're going to have it not equal to 0 because we don't want our denominator to be 0. So these are the values which will make it 0, which is what we don't want. So that's why it's our NPV. Cool. So now I want to do this one. So we're going to simplify first. So we have our first step is going to be to factor. So let's factor the numerator here. So what's common between these two? 6. So we have x plus 2 here on top. And then the denominator we can factor by inspection, or factor by decomposition. So remember the AC method. So two numbers that multiply to give us negative 24. Two numbers that add to give us our middle term, which is 2. So we have 6 and negative 4, 6 and negative 4. Because 6 and negative 4 multiply to give us negative 24, but add to give us 2. So now what we're going to do is we're going to break down our middle term here into our factors that we just found. So 6x and 4x. And again, you're just going to factor and solve by decomp. So what's common between these two is going to be a 3x. And what's common between these two is going to be a negative 4. So you get 3x, x plus 2, negative 4, x plus 2. Remember that we're grouping these two. You get 3x minus 4, x plus 2 as your factored version. So we're going to plug that back into our denominator here. So we have 3x minus 4 and x plus 2. And again, we're just checking our denominator and our numerator to see if there's anything common that we can cancel out. So in this case, we have an x plus 2 in the denominator and the numerator. So we can cross these two out. You're going to get 6 over 3x minus 4 as your simplified version of this expression. So now let's go back here and let's do the NPV. The NPV is just the numerator or denominator. Remember that. So we're just looking at this bottom term here. So if you remember, we factored this down, this denominator already. We factored it down into 3x minus 4 and x plus 2. This is what we factored earlier. So right now, what we can do is we're just going to set both terms not equal to 0. And get 3x minus 4 is not equal to 0. And x plus 2 is not equal to 0. And again, just solve for x. And get x cannot equal 4 over 3. And x cannot equal negative 2. So that will be your two answers for your NPV there, as well as your simplified expression. And if you want to check if your answer is actually correct, what you can do is you can actually plug these values back in, and they should give you 0 just into your denominator here. And if it gives you 0, then that means your NPVs are correct, because we don't want to be dividing by 0. And these are the values of x that actually make our denominator 0. So that's a big problem, and we don't want that. So again, cool. Moving on. We're now going to be solving a rational equation. 6 over 2x squared plus 2x is equal to x minus 2, x plus 1. Okay, so the first step here is we want to find our lowest common denominator. Okay, so we have 6 over 2x squared plus 2x is equal to x minus 2, x plus 1. Okay, cool. So again, what I want to do here is we're going to factor first. So 2x squared minus 2, we can factor out here is a 2x. So you get 2x, x plus 1 as your factored version of this. So if you notice here, we have an x plus 1 already. So again, so we have 2x, x plus 1 is what this factors down into. So our LCD is what is going to be our lowest common denominator between these two. So this one has an x plus 1. This one has an x plus 1. But what we're missing is that 2x in front of it. So our LCD is going to be 2x, x plus 1. Since we don't have to change anything on this side, since we already have our lowest common denominator, what we're going to do is we're actually going to change our right side. So what we can do is we multiply both the top and the bottom by 2x. And now you're going to notice that your denominators are equal, which is good. Now that they're equal, we can actually cancel them out. So now we have 6 is equal to x minus 2 times 2x. Now what we can do is we can actually FOIL this in and get 6 is equal to negative 4x, wait, yeah, 4x squared minus 4x. Or sorry, it should be 2x squared. 2x squared minus 4x. And now what we're going to do is we're going to subtract 6 from both sides. And now you have a quadratic equation where you can solve for both your x values. So what I'm going to do here is I'm going to divide everything by 2 since we have a GCF of 2. So get 2, get x squared minus 2x minus 3 with our 2 in front of it. Now what we can do is we can factor what's inside here by using inspection, which is nice and easy. So two numbers that multiply to give us negative 3, and two numbers that add to give us negative 2. So we have negative 3 and 1, and negative 3 and 1. So what that should factor down into is x minus 3 and x plus 1. Now what we're going to do is we're going to set both of these equal to 0. So x minus 3 equal to 0 and x plus 1 equal to 0. And this should be a kind of recap from what we did in unit 2. And we're just going to solve for x here. So we get x is equal to 3 and x is equal to negative 1. But remember one thing, when we have our solutions, we need to make sure that both actually work. Because sometimes there can be cases where our solution is actually our NPV. So let's be careful. So we have 3 and negative 1. Just remember that. So now let's find the NPV to our solution. So we have 2x squared plus 2x. And we said our LCD was 2x, x plus 1. Cool. So if this is our lowest common denominator, we have x plus 1 over here. So let's set both of these not equal to 0, since this is what this factors down into. So we have 2x, x plus 1. And since this left side covers this x plus 1 here, we don't have to worry about that. So we have x plus 1, and we're going to set that not equal to 0. And we have 2x not equal to 0. So we just subtract 1 from both sides, and you get x is not equal to negative 1. And you divide both sides by 2, you get x is not equal to 0. So our NPVs here are going to be 0 and negative 1, which x cannot equal. However, remember that one of our solutions was negative 1, and since our NPV is also negative 1, that means we have to actually determine this as an extraneous root. What that means is it is a reject. So it's a reject solution that won't count, because if we have a negative 1, then we will have an undefined equation. So our only valid answer here is going to be x is equal to 3. So again, it's a little sneaky there, and you have to be kind of, on top of what you're doing. Just making sure that your NPVs and your solutions don't actually match up. And if they do, make sure you're canceling it out for that very reason. Cool. Now we have a word problem here. We have Brendan and May are ecologists studying forest regeneration. Working together, they can count the seedlings on a research site in 2 hours. It takes Brendan 8 hours to count the seedlings if he were to do it on his own. And it would take May to count. How long would it take May to count her seedlings on her own? If necessary, round the answer to the nearest tenth of an hour. Okay, so to begin with, we have to make one of those charts. So there's two types of charts we have with these word problems. We have our distance, speed, time chart, and we have our collaboration chart. And what that means is hours work together. So, or painting together or working together overall. So these are two charts you have to make sure you're familiar with. So let's begin by making our first chart here. So let's look at this. So let me just grab the shape here. And I'm going to draw this 3-prong chart. So this is going to be time. And this is going to be our fraction of t time. Fraction of time. So, okay. So what this is going to be Brendan. This is going to be May. And I need to make another slot because I need to get one where they're working together. Together. Okay, now that we have this chart here, we need to look and actually fill it out. So let's see. It says that it takes Brendan to do it 8 hours if he were to do it on his own. So we're going to put 8 for Brendan. Working together, they can do it in 2 hours. So we're going to fill this out. So what is our unknown here? Our unknown is actually going to be May's time. So we're just going to put our time or our variable t over our time. Okay. So if you take a look here, what is our fraction here? So we have t over 8, which is our time. Again, we're just putting our variable over our fraction here. And we have t over our time, which is going to be t, since it's our unknown. And since t over t, we're dividing by the same thing. This is going to be equal to 1. And then now we have t over our time here for together, which is 2. Cool. So remember that we have this equation here, which we're gonna form an equation here. So we have Brendan's time plus May's time, in theory, should give us our time worked together. So now that we actually have this, we can actually make an equation. So we're going to take our fraction of time here and form this. So what is Brendan's fraction? So we have t over 8 plus our May's time, which is going to be 1, equals our together time, which is t over 2. Cool. And now all we have to do is we have to solve this rational equation. So we have to find our LCD. In this case, our LCD is going to be 8. Since we can multiply, we don't have to change this, and we can multiply this by 4 and this by 8. So pretend this is a fraction of 1 over 1. And that's how we're going to do that. So we pretend this is 1 over 1 here. So our LCD is going to be 8. So you have t over 8 plus 1 times 8 times 1 over 8. And to make this actually equal to 8 on the bottom, on our denominator, you have to multiply both sides by 4. And so 2 times 4 gives us 8. So now that we've made all our denominators equal, remember from our last one, we can actually cancel out all of these. And what you're going to be left with is t plus 8 is equal to 4t. We're going to subtract t from both sides and get 8 is equal to 3t. And then now you isolate by t for t by dividing by 3 and get 8 over 3 is equal to t. And when you evaluate this is going to give you approximately 2.7 hours rounded to the nearest tenth. So May's time is going to be 2.7 hours. And that is how you do that word problem. Now we have a speed time one. So this is the second type of chart that we're going to be taking a look at. So again, make yourself familiar with these two charts because you're going to be doing a lot of these, and just make sure you know how to do them. Okay, so taking a look at this. So since this chart is made for us, it's very nice. So we just have to look at a couple keywords. So Lucas drove 210 meters and Don drove the remaining 345. Don drove 10 kilometers faster than Lucas, and the total trip took 5 hours. So you may think that 5 hours, right? You're just going to put that in time, 5 hours. But no, that is not what we actually have to do here. Let's fill out our distance first. So Lucas drove 210 kilometers. And Don drove 345 kilometers. Don's speed was 10 kilometers faster than Lucas's. So Don's speed, or Lucas's speed, could be X. And Don's speed can be X plus 10, because it's 10 kilometers faster. So this would be his speed in kilometers. And this would be his speed if it was kilometers, 10 kilometers faster than Lucas's. Good. So now we've actually kind of created an equation, or created an expression for speed. Now we have to actually create one for time. So we have to ignore what the time is here for now, because that is not useful in our distance speed time graph, or distance speed time in this chart here. So remember the distance, speed, time. So again, the way we find time in this case is we have to divide distance by our speed. So to find time for Lucas, we have our distance, which is 210, and we're going to divide it by our speed, which is X. We have Don's speed, which is 345, and we're going to divide that by X plus 10. And that is our time. You're probably wondering, like, where did this even, where does this 5 hours come in, right? So now, this is the equation that we're going to make. So, Lucas's time, we have to, let's just write it out before anything. So Lucas's time plus Don's time should equal the total time, right? Because they drove the same car in the same car. So cool. We have, this is where this 5 hours actually comes in now. So let's plug in Lucas's time. So Lucas's time is going to be 210 over X plus 345 over X plus 10. And this is all going to be equal to our total time, which is 5 hours. So we'll write that as 5. Okay, now we actually have to look for an LCD. So this might be a little hard. So what we have to do is, again, look what's common here. So X plus 10 is going to be part of our LCD. So X plus 10, bracket maybe. But also we have this X, which is unwarranted. So we're just going to add that there. So X times X plus 10 is our lowest common denominator, because there's nothing here that we have to worry about. But again, we have to do this. So 210 over X. And if our lowest common denominator is X times X plus 10, since we already have this X, we don't have to multiply by another X. All we have to do is multiply by X plus 10. And also multiply the numerator by X plus 10. Because, yeah. Cool. Now we have to multiply by what's missing in our denominator here. And since we have an X plus 10, but no X, we have to multiply both the numerator and denominator by X. So 345 times X is equal to 5. But our 5 also is a part of this equation, so we have to multiply it by, pretend it's a 5 over 1, X times X plus 10, since it's missing both. And now we all have the same denominator. So now we can cross out every denominator here. You're going to get 210 x plus 10 plus 345x is equal to 5x times x plus 10. Okay, now that we've gotten that, what we actually have to do is we actually have to FOIL now, and we actually have to distribute this 5 onto here, and so forth. So, and over here. So again, 210 times x is going to give us 210x plus 210 times 10, which should be 2100, plus 345x is equal to 5x times x plus x minus 10, which turns into 5x squared plus 50x. Now that we've FOILed and distributed everything on, all we have to do is move all of our terms to one side. So I'm going to move these two terms to the other side. So, first we actually have to collect these like terms here. So what that comes down to, so 345 plus 210 should give us 555x. So plus 555x. And now we can actually move everything to one side. So minus 5x squared from both sides. And that cancels out, and we have to minus a 50x. So minus 50x from here. So now that this side is all canceled out, we're going to have it equal to 0. And on our left side, we have negative 5x squared plus our 505 minus 2100. Cool. Now that we've actually done this, what we can do is use the quadratic formula here to actually solve for our equation. Since it's so big, we can't use our factoring. We can't use we can't use factoring to solve this. So what we can do is quadratic formula or complete the square, or actually graph this. So what I'm going to do is I'm going to plug this in, and we're going to do the quadratic formula. So what we've got from our quadratic formula is this here, which is x is equal to 505 plus 445 over 10. And now what we can do is we can get our two roots here, which should give us x is equal to 1 over 105, and x is equal to negative 4. And immediately what you're going to notice is negative 4, right? Negative 4 doesn't make sense because we can't have a speed of negative 4 kilometers per hour. So this is going to be a reject solution. And what we're going to have here is we're going to have Lucas's speed as 105 kilometers per hour. However, remember that Don's speed is equal to Lucas's speed plus 10. So we have 105 plus 10 is equal to Don's speed. So 105 plus 10 is 115, meaning Don's speed is going to be 115 kilometers per hour. And that is going to be your answer to this word problem here. Cool. Alrighty, I'm going to do this one last example here, and then I'm going to show you guys how to do some calculator tricks. So this one says to state the non-permissible values and also simplify. So again, we're going to be dividing here. So we have 9w plus 36. And I just want to begin by factoring again. So what we can do here is we can actually factor out a 9. So 9w and 36 divided by 9 gives us 4. So that will be our fully factored numerator. So let's factor this denominator here. So we have two numbers that multiply to 28, but add to give us 11. So two numbers that multiply to give us 28 is going to be 7 and 4. And add to give us 11 will be 7 and 4. So since we're factoring by inspection, I'm just going to put a W in front of our two numbers here. So W plus 7 and W plus 4 will be our fully factored denominator there. Let's go. And now, since we're simplifying, remember that when we're dividing, what that means is we're going to be multiplying by the reciprocal. So if you're unsure what that means, all we're doing is we're just going to be flipping this fraction here and multiplying by what we flipped it by. So multiplied by W squared minus 49 over 3W minus 12. So what this simplifies into is W squared minus 49. That is going to be a difference of squares, since W squared is actually a perfect square, perfect square, and 49 is actually a perfect square as well. So what this turns into is W plus 7 and W minus 7. And our denominator has a common factor of 3. Let's factor out a 3 there. So we have 3 and 12 divided by 3 gives us -4. So when we're multiplying, all we have to do is just smash all of these terms together. So we have 9, W plus 4. So we're smashing our numerator with our numerator and our denominator with our denominator. So W plus 7, W minus 7, all over W plus 7, W plus 4, and we have 3 W minus 4. Again, we're looking what we can simplify here. So 9 over 3. 9 divided by 3 is 3. So that simplifies to our 3 here. W plus 4. Do we have a plus 4 on the bottom? So we do. So these cancel out here. So we don't have to write that. We have a W plus 7, which is common. And they cancel out as well. So now we're left with W minus 7 over W minus 4. And take a look at this. I think we did that right. Yeah. So that will be your fully simplified version of this. And just remember this answer, because I'm going to come back to this and I want to show you how you can actually double check this within your calculator. All right, now when we're looking at NPVs for this, right, we have two terms and it can be a little confusing. So let's just take a look at this. So we have this part of our denominator of our first term, which actually stays the same so the entire time. So the entire time it stays the same. So if we remember earlier, we actually factored this down into W plus 7 and W plus 4. So since it stays the same, we can be 100% sure that this is a static NPV here. So it's going to be 100% sure here. So again, we're just going to set both terms equal to 0. And get W is not equal to 7, -7, and -4. So that is two NPVs right off the bat from our first term. Now we actually have to look at our second term, right? So you're probably wondering, you're like, oh, since we're dividing, do we actually have to consider the denominator of the original? So we're like taking the reciprocal. And the answer to that question is actually yes, we actually have to. So this original denominator here factors down into W plus 7, W minus 7. And remember, both sides are not equal to 0. And this gives us x cannot equal plus or minus 7. And since we have a -7 here, we're just going to add our 7 here. And that is the contribution from this denominator before we divided it. So when we divide it, remember, we take the reciprocal, right? So we actually flip this. So this 3W minus 12 will actually go on the bottom. So that is going to be an NPV too. So basically, whatever you're dividing by, this term and this term will both be NPVs because you're taking the reciprocal. Because this was at the denominator at one point, and this is going to be at the denominator at another point. So again, let's just set this not equal to 0 and add to both sides and get W is not equal to 4. And basically, those are going to be your 4 NPVs here. So you have plus or minus 4 and plus or minus 7 as your NPVs, which is what x cannot be equal to. that's cool. Now we are done. I'll show you guys. So to begin with, what we have here is our equation that I've typed out by hand. So we have our original equation here, and this is exactly what it looks like. If you were to do this on a different calculator that is not the TI-84 plus CE, you'd actually have to manually type in each bracket, kind of like this. So you would get, it would look like this. So you'd have to put an extra bracket around everything and get x squared 11x. So it's a lot more that we're doing, and it can get a little confusing at times, right? So that's the problem with this kind of method of checking. You have to make sure that you're very precise with your brackets here. So I think this is okay. Sure, this like this. So that is the first part of that expression, and we're containing it all in one bracket because we're going to be dividing it by our second term. So divide this by our second term, which is going to be 3x minus 12, and make sure you're including, like, it's a lot, divided by x squared minus 49. And that is how it'll look like if you're doing it by hand. And again, it's going to give the same result. It's just going to be overlapping. Make sure you're putting one bracket around each individual term. So like this, when you're typing it into your calculator, but also one whole bracket to contain these two. So it'll look like this. So one set of brackets around each individual term, and one set of brackets separating each part of the equation here. So again, it's the same thing, but it's just a little more tedious. So now that you've typed in your original equation, you have to type in your simplified version. So we have this as our simplified version. So you have 3, and instead of w, we're going to put x minus 7. And I'm putting an additional set of brackets again, because we have to include this. Like that. And we're going to put in brackets w minus 4. So now that we've put that in, that is your simplified version, and we're going to compare it to your original version. And you're going to notice that when we graphed our simplified version, it actually had an overlap, meaning that our expression is equivalent to the one we just put in. So this is a way you can double check if you've actually done it right and ensure that you actually have the same line and same thing. So this is one way to, again, double check and make sure you've simplified properly. And I would only recommend doing this with like really, really long like expressions that are gonna, be worth a lot. Like maybe a written response is something you might want to take a look at this if you have free time, again, of course. But this is one way you can, again, double check and make sure. Another thing is I want to show you how to find NPVs on our graphing calculator. So again, just type in your original equation. Make sure you type in an original equation for NPVs. So I'm gonna let that graph out, and effectively what I'm doing here is I'm looking for the asymptotes, okay? And if you're not sure what an asymptote is, it's basically the lines where x cannot equal. So an asymptote is effectively the same thing as an NPV. So all we have to do is we have to go second and then table. And then we're going to look at our values, right? So we have -7 as one of our NPVs, which is what we said. And then we have -4, which is one of our NPVs, which is what we said. Again, and then we're looking at 4, which gives us an error. Again, it's an NPV because it has an error there, which is meaning y value doesn't work there. And we have 7. So every NPV that we've listed here, -7, 7, -4, and 4 are all correct NPVs. Again, because our calculator is displaying this error message where we have those values. And if you're wondering, like, let's say we get our NPV as 3/2, right? 3/2. And if our NPV is 3/2, if you go on your table, you're like, what? How do I do this, right? There's no whole number. So the way you actually do this is you have to actually go second trace, and then you input manually a value. So if you put 3/2, and if it's an NPV in your original equation, then it should be giving you an error or no y value for x, or y value here. So there's a y value right here. And if it's NPV, there should be nothing, or it should say error. And that's how you know you're correct. And that's how you check when it's a weird, fraction form. Just make sure you're doing that, and yeah, it should be fine. That is how you check NPVs, but also check your simplified solution within your calculator. All right, real quickly here, we're going to be going over some of the answers to some practice questions here. So this is asking for the non-permissible values of this expression. So we have x squared plus x minus 20. And we're looking at purely the denominator for the NPVs. Remember this, because NPVs are, again, where our denominator is equal to 0. So let's just factor this. So we get two numbers, then multiply it to negative 20 and add to give us 1. So we have 5 and negative 4, 5 and negative 4. We can factor this by inspection. So we get x plus 5 and x minus 4. And now we get x is equal to negative 5 and positive 4. So whichever answer has negative 5 and positive 4 is going to be our answer. So our answer is going to be D, and that's going to be our non-permissible values. Again, if you're unsure, what you can do is you can plug all of this into your calculator. But since this is a really simple and easy one, I wouldn't recommend doing that. So yeah. And all right, question number 4. So we're looking at a student's solution for simplifying the quotient of two rational expressions. So the quotient of two rational expressions means, quotient means to divide, right? So if we're dividing, we're going to be taking our reciprocal. So what the student did is they factored this down in x plus 6, x minus 6, which is right, and factor this into this, which is right. So again, quotient is going to be dividing, so we're going to take the reciprocal here, which is what they did. So far it looks really good. So right now they've smashed these all together and cross out what's common between them. So this step looks good. And now where the problem actually arises is this should simplify into x plus 6 over x plus 3. So this step right here is where the student made the error, because they put 6 squared. And 6 squared doesn't cancel out like this. So that's why our student's error is going to be in this step. Alrighty, question number 6. So this one's a bit tricky. We have an airplane travels 500 kilometers with the wind in the same time that it takes an airplane to travel 400 kilometers against the wind. The average speed of the plane in still air is 180 kilometers. What is the average speed of the plane? What is the average speed of the wind? Okay, so again, here we're not going to be looking for the speed of the plane. We're going to be more so looking at what the speed of the wind is affecting the plane. So we have our two distances here, which are going to be important. We also have our plane in still air. So I'm going to show you what this actually means. So remember, we're going to create a table here. And there's two types of tables we're going to be creating. Remember, we have the relationship one where we have two people working together. And yeah, this one is going to be our distance, speed, time. So just make sure you're familiar with both. Right now, we're going to fill this out. So our first plane is going to be one with air. So with the air. And we have the other one, which is going to be without the air. Or what I'll say is against the air. So against the wind will be our second plane here. So our first plane travels 500 kilometers with the air. And our second plane going against the wind travels 400 kilometers. So it's a little bit less. Our speed of the plane in still air. So still air, that means we have no effect. The air has no effect on the speed of the plane. And you're going to notice that these two are both affected by the speed of the plane. So this is the speed normally without any external factors. The external factor of air attributing to its speed. So what that means is we have 180 for both. And since we're going with the air on the first one, we're going to have plus. Because if we go with the year, that's going to increase the speed. And if we go against it, it's going to decrease the speed, which is going to be minus x. So minus x is going to be minus the speed of the wind, and x plus x is going to be plus the speed of the wind. So x is going to be equal to our speed of the wind, which is what we're looking for in our equation. So we're just going to be looking for what x is equal to. So now we have our, remember our distance, speed, time triangle, where time is equal to distance over speed. So we're going to have 500 over 180 plus x. And for the bottom one, we have 400 over 180 minus x. And one key note is that they take the same time. So if they take the same time, that means we can set our times equal to each other. So we have 500 over 180 plus x is equal to 400 over 180 plus or minus x. And in this case, I'm going to cross multiply. So we get 500 times 180 minus x is equal to 400 times 180 plus x. Now you can actually pull out your calculator here. So I'm going to do this. So we get 500 times 180 gives us 90,000 minus 500x is equal to 400 times 180 which gives us 7,200 plus 400x. So now I'm going to move all of these to one side. So let me just this all the way. So what we can do is we can subtract 7,200 from the side. Subtract 7,200 from the side. And that gives us 90,000 minus 7,200, which gives us 1,800. And those cancel out. So now we have to subtract 400 from this side, or what I'll do is I'll add 500 to the other side. 500x plus 500x. And that gives us 500. 1,800 is equal to 900x. Now we divide both sides by 900. And x is equal to 1,800 divided by 900, which is 20. So our speed is 20 kilometers per hour. So that is the speed of the wind. So the plane traveling with the wind is going to be traveling 200 kilometers per hour. The one without is going to be 160 kilometers per hour. And the speed of the wind, which is what the question is asking, is going to be 20 kilometers per hour. And that is going to be how you do this final question here. Alright, final question I would like to leave off on is one that we're finding the perimeter. So I'm going to pull it up and we're going to try to do this together. So here we have to find the perimeter of our given equation, given that we have two side lengths. So again, it says if our perimeter is equal to 1, what is our x values? Okay, so the way we set this up is remember that perimeter of a rectangle is equal to 2 times width plus 2 times length is equal to our perimeter. And it's in this case, which is going to be 1. So all we have to do is we have to plug in our values. So if this is our width and this is our length, we have 2 times 5 over x minus 4 plus 2 times 4 over x plus 4. So, and this is going to all be equal to 1. So remember when we're multiplying by 2, it's going to be a 2 over 1 here. So we're just going to be multiplying by our numerator. So we're going to get 10 over x minus 4 plus 8 over x plus 4. It's going to be equal to 1. Now we actually have to find our LCD. So our lowest common denominator here is going to be x minus 4 and x plus 4. So x plus or minus 4. Okay, so What this equation here, what this side of the equation here is missing is x plus 4. So you can multiply this by x plus 4 and our denominator by x plus 4 plus 8 over x plus 4 x minus 4. And since our 1 has neither, we're going to be multiplying this by plus 4 and x minus 4. Close this bracket here. So now that we've done this, we can cancel out all our denominators since they're all the same. Just pretend I did this on the bottom here. You're going to get 10x plus 4 plus, what do we multiply here? X minus 4. 8 times x minus 4 is equal to x plus 4, x minus 4. So now what we can do is we actually have to FOIL everything out and collect our like terms here. So what I'm going to do here is I'm going to FOIL this out here. So you get 10x plus 40 plus 8x minus 32 is equal to x squared minus 4x plus 4x minus 16. So x squared minus 16 on this side. Now all we have to do is just collect like terms over here. So we get 18x minus or plus 8 if we collect this here, and is equal to x squared minus 16. Now we can move everything to one side. So I'm just going to move this x and this 8 by subtracting both. 0 is equal to x squared minus 18x. And if we're subtracting 8 here, then we're going to have minus 24. And now what this is going to be simplified to is so for this one we're going to be using our quadratic formula. So we're going to get one sec. It's going to be A, B, C, and we're just going to plug it into our quadratic formula. So plus or minus the square root negative 18 squared minus 4 times 1 times negative 24 over our 2 times our A value, which is 1. And this is going to give us x is equal to 18 plus or minus 20.49 over 2, which then gives us two answers here. We have 19.25 or negative 1.25. So this solution here is going to be a reject because we can't have any negative dimensions, remember that? And it's going to be 19.25 meters, which is equal to x. So if it's asking for our length and width here, we can plug in 19.25 to get our new length and our new width. But if it's just asking for what x is equal to, then we have this as our answer for that. Now, in terms of NPVs, all we have here is going to be, since our denominator is x minus 4, so x minus 4 cannot equal 0. We just add 4 to both sides. So get x cannot equal 4 and x cannot equal negative 4 from this denominator here. So those are going to be your restrictions in this case. And that is going to be how you do perimeter when given two side lengths and asked to simplify and solve a rational expression. Alrighty, thanks everybody for watching. This one was a little bit of a shorter one, and that's because I just wanted to be fast and concise. So I hope it helped. I really hope it did. I wish everybody good luck on their unit, and that'll be it for me. So if you guys have any questions, leave them in the comments. And if you have any feedback for me, that'd be nice as well. So yeah, otherwise, I will be out now. So thank you guys so much for watching this. Goodbye.